Hey guys, welcome to mathspays.com. Today we're looking at trigonometry applied questions or application of trig questions. Okay, so just a couple of things to note first of all. Number one, the most important thing is you must draw a diagram if it's not drawn for you. Okay, so draw a diagram. Now when you are drawing a diagram, a couple of things. Make it big. Alright, make it big. So usually if I'm in an examination, I'd make it like 1/3 of a page probably. So you can clearly draw in all the angles and those types of things. You want to make it clear as well. Okay, so really clear, and make sure that that you've got on your answer sheet so that we can actually check your working out, etc. After you've done that, you need to identify the rule that you're using. Okay, so I mean obviously your sine, cos and tan from your SOHCAHTOA. All right, that's really important. And then third part of it, solve and answer the question. Now I always say to go back and have a look at the question. Doesn't look about right. Okay, so first of all, we're going to give a nice easy question to start off with because the diagram's been constructed for you, of course. You might want to pause this, guys, and have a go at it, and then come back and check your answers. Okay, so we've got the angle of depression now. Hopefully you remember the depression means you look out across, and then you look down to the point that you're looking at. So it says the angle of depression from the kookaburra's feet to a worm on the ground is 40 degrees. And I've got that drawn out nicely for us. Of course, you might remember too that the angle of depression is also equal to the angle of elevation. Okay, and that's from that angle called the alternate angles. Okay, or Z angle as some people might refer to it as, but alternate's a better name for it. We've got the worm that is 15 meters from the point on the ground directly below the kookaburra's feet. So we've got the 15 meters there drawn out nicely. And we're wanting to find out how high the ground are the kookaburra's feet correct to the nearest meter. So I guess that could be our X or our H. Okay, now if you kind of like to redraw things, you certainly could redraw this triangle to make it look a little bit nicer or a little bit more like our trigonometry. So we've got our 40 degrees there, we've got our 15 meters there, we've got our H. Of course, it's not necessary to do that, but you might find it easier. Okay, so step one, okay, we've got our diagram, all right? Step two, we need to identify the rule that we're using for SOHCAHTOA. So in regards to 40 degrees, we've got our opposite, and we've also got our adjacent side, which hopefully you remember now to be our tan rule, okay, our TOA. So tan theta, in this case it's tan 40 degrees, is equal to our opposite, so our H, over our adjacent, which is 15. Now, this is quite nice because 15 is on the bottom, so the opposite divided by 15 is times by 15. So it might be a good idea to rewrite this now. H equals 15 times tan 40, or you can even write 15 tan 40 if you wish. And then we simply type that into our calculator, 15 times tan 40 to get our answer. Now, in this case, I always like to write down what's on my screen to at least 3 decimal places and put my ellipsis there. My dot just means it continues on. I go back to the question, and the question's asked to the nearest meter, so therefore the height equals 13 meters. Alrighty, next question, guys. It's probably not as just as easy, I reckon. Not very challenging, but again, pause it, give it a crack, and see how you went. Okay, so step one. We've got a diagram there drawn perfectly for us. It's asking for the height above Danny's hand. So this is the triangle that we're using. So if you really want to redraw this out, you can. There's not really a need for it, but certainly if you wish to, you can. Okay. So step one, we've got a diagram given to us. Step two, we want to identify the rule that we're using. So in regards to theta, we've got our opposite side, we've got the hypotenuse side. So we are looking at, of course, our sine. So sine 55 degrees equals our opposite over our hypotenuse. This is another nice question, guys, because we can simply times it by the 80. So h equals 80 times sine 55, and then that's another matter of putting that into our calculator. You can put a times in there if you wish, you don't usually have to, but if we do that, we get 65.532 ... Now this is in meters, of course, and it says to the nearest meter, so therefore h equals 66 meters. Now, of course, this is not drawn to scale, so sometimes when we look at it, we go, oh, that doesn't really look like it's 66 meters. The hypotenuse is 80 meters, so 66 meters in terms of the triangle, that sounds quite reasonable. Okay, so that's quite a good question. Okay, we've got two more questions to go. I'm going to finish off, well, the last question is quite challenging. This one's not so bad, but again, a little bit different. The angle of depression we've got here of the base of the tree from the top of the building is 65 degrees. And they haven't drawn this in, but we've already mentioned it. Okay, we know that the angle of depression, we look across and then we look down to the point that we're talking about. So it says the angle of depression of the base of the tree from the top of the building is 65 degrees, which means that my angle of depression is also 65 degrees. Now, I like to always draw both of them in. I think it's quite important, but theoretically you don't actually have to, but I like it anyway, and I would ask you to do it if you're in my class. Okay, so what do we got? We've got the height given to us as well. That's 30 meters there. And then the question is saying, how far away is the base of the tree from the building? So I guess that's our x there. So like last time, if you really wish to redraw the triangle, it's up to you. I don't do it all the time, I must admit, but I'm going to do it for us. So 65 degrees, got our x, we've got our 30 meters there. And so step one is complete. Step two, of course, we now want to find our rule, identify our rule. So within 65, we've got our opposite, we've got our adjacent. So we're using tan 65 is equal to, this time is our 30 over our x. Now, this one is slightly more challenging, of course, because we have x on the bottom. So if you remember the quick way, you can just flip the x and tan 65 around. The reason for that is because we're timesing by the x to get it off the bottom of the fraction. And then we're dividing, because that's the opposite of times tan 65, we're dividing by tan 65. But a lot of the time, guys, you'll just learn just to flip those around. But we're going to have x is equal to 30 divided by tan 65. And now we can plug that into our trustworthy calculator. You can use the fraction key if you wish, or you can just use divided by sign, which I often do. And we get 13.989. ... Now back to the question. It says correct to one decimal place. So therefore x is equal to, well, one decimal place would be the 9 that I'm rounding. The 8 says it goes up to a 10. So I'm going to have 14.0, and it's measured in meters. And that there, my friends, is my answer. Okay, 14 meters. Okay, now the last question, I'm going to warn you, a little bit tough, okay, but I want you to have a crack at this question. Actually, that's not a tough question at all. Actually, it is a tough question. Have a go at this. It's a bit more challenging than what it might first seem, but it's more a problem solving or a working mathematical question. So see how you go. Okay, guys. Hopefully you had a good crack at this question. So we've got a wooden framework is built as shown. Bella plans to reinforce the framework by adding a strut from C, okay, so obviously you can see C's up here, to the midpoint of AB. Well, hopefully we've done a bit of linear modeling, so we should know the midpoint means the middle of AB. So what we're doing, we're putting a wooden strut from that point. Hopefully yours is a bit straighter than mine. And they're asking for the length of this strut. Okay, x is going to be there. Okay, so at first kind of value, face value, it doesn't look too hard. But if I look at this little triangle inside here, there's a bit of an issue, because I always say look at Pythagoras first. Can you use Pythag? All right, that's not a bad way to start because Pythag can be used in many of these questions, but it can't because for Pythagoras to work correctly, we would need to know the length of this part here. Let's call that TB, right? We need to know that length. And then we could do a squared plus b squared equals c squared, but that's not going to work for us, all right? We can't even use trigonometry at this point either, unfortunately, because in this triangle, we don't have an actual angle either. We don't know what the angle inside there is going to be. So we're a bit stuck. But of course, there's more to it because there's a bigger triangle. We've got this real big triangle here. Okay, that's 5 meters there, and that's 38 degrees there. But I did mention to you before that if I knew this length here, let's call this the length of y, then we could probably use Pythagoras Theorem. We do know that TB is half of AB, all right? So that means if I know what AB is, this entire length here, all right, we can figure out what half it's going to be, what TB is going to be. So we are using trigonometry, it's just we're using it in maybe at 2 different steps. So in terms of this triangle here, triangle ABC, what we've got here, with regards to 38 degrees, we've got our opposite and we've got our adjacent. So we're going to start by using tan. So tan 38 degrees is equal to 5 over x, opposite over adjacent. Now, if we know the quick rule, we can swap the x and the tan 38 around by timesing by x and dividing by tan 38. So 5 over tan 38. I'm going to chuck that into the calculator. So 5 divided by tan 38. And it also is important to use the answer that's in your calculator. Don't round early, guys. That's a real bad habit to make. I'm going to put 3997 and ... Worst case scenario, use like 4 or 5 decimal places. That should get you around. But I'm going to hopefully use my answer key. So that's what x is. So if I want to find out what TB is, well, that's simply half of x, so I'm going to divide it by 2. And that's going to give me 3.19985 ... So if I redraw that initial triangle out, which I've got my T, my B, and my C, we know that was 5. We now know that this is approximately 3.19 ... And what we can now do is use those two sides by using Pythagoras to find y. All right, so I'm going to say my 3.19 ... squared plus 5 squared is equal to, we'll say, y squared. Now I'm going to still use this in my calculator, so the answer's still there. If not, write that whole number out and press squared. But I'm just going to square it now in my calculator. I'm going to add 5 squared. And I come up with y squared is equal to 35.239 ... And so obviously to get rid of the square, we're going to square root. And of course, this is a measurement, so it's not plus or minus. Okay, we just square at the answer. And we come out with 5.936. Now, look back at the question. It says, doesn't mention how, like many decimal places, so I'm going to do it to 1. So 5.9 meters long. And that's how big that strut's going to be there. And the good thing is that looks quite realistic, right? Because we know that the hypotenuse has to be bigger than the 5 meters here and the 3.19 meters here, and 5.9 looks quite reasonable. Okay, so in that case, we've used trigonometry and then use that back to find Pythagoras to find the answer. Guys, that's a very challenging question, particularly for year 9. Year 10 is probably a decent question, but certainly it's doable. Remember, we're just going to revisit. The first step is always, no matter what happens, okay, draw a diagram if you haven't got one. 2, identify the rule that you want to use for your SOHCAHTOA. And then last of all, answer the question. And I might just say too, check the rounding. okay, because you don't want to lose silly marks for not doing to nearest meter or nearest decimal place, etc. Alright guys, it was a bit of a long lesson, but I hope that kind of made sense. They are the more challenging questions that you will find, but certainly if you follow those 3 steps, guys, you can really make a good effort in getting these questions right. Have a great day, guys,